I am Dr. P. Geeta, Assistant Professor of Mathematics, V. Vanniperumal College for Women, Virudhunagar. I am going to discuss about Simpson's rule in numerical integration. Before entering into the concept, we must know about what do you mean by Simpson's rule. Simpson's rule is used to find the area under the curve. What is the concept behind this Simpson's rule is, suppose we want to find the area of any object, that object having any shape, first we are going to draw the curve corresponding to the object, and then we are going to evaluate the area under that curve. In engineering, most of the engineering problems, Simpson's rule not only give the value of the definite integral, we need the approximate value of that integral. In that case, we have to apply Simpson's rule in numerical integration. Simpson's rule was first discovered by the British mathematician Thomas Simpson, which is used for approximating the value of the definite integral. Suppose we want to find the area of any object. Just we outline the curve of the object, just like that. Now we are going to evaluate area under this curve. So this area that represents the area of the object. So what we have to do first? First we divide that interval of the area into A to B. That is, now we are going to define the value of the area between the closed interval A to B. For that one, first we divide the entire area into n even number of equal segments, that is x1, x2, x3, etc., xn. And then here each one is an equal section. Now we approximate this section by the parabolic curve. So now we are going to join these by the straight lines. Now I am going to approximate this by the curve, parabolic curve, in between the interval x1 to x3. And this gives the area between these segments x1 to x3. Next we are going to determine the remaining section x3 to x5. So in this way we are determining the area of the smaller section by the polynomials. Now sum of the area of the polynomials, that gives the area under the curve, that represents the area of the object in any shape. Simpson's rule states that we are evaluate the area of the curve between the interval a to b, f of x into dx equal to delta x by 3 plus into f of x naught plus 4 into f of x1 plus 2 into f of x2 plus etc. 4 into f of xn minus 1 plus f of xn. We divide the entire area into even number of segments, and then each of the section is determined by the formula delta x, which is equal to b minus a by n. And then each xi can be calculated from a plus I into delta x. Here we represents the curve f of x by y, and then which is equally spaced between the interval a to b. That can be represented by the ordinates x0, x1, x2, etc., xn. And then initial value of the ordinate is x0, next x1 is x0 plus h, and then x2 is x0 plus 2h, etc. xn is x0 plus 10h, where h is the difference between the terms. And the corresponding value of the function f of x0 is y0, and then f of x1 is y1, etc. f of xn is yn. And then here you have to find the each value of y by each value of x. And this also can be represented by h by 3 into y0 plus yn plus 4 into y1 plus y3 plus yy, etc. yn minus 1 plus 2 into y2 plus y4 plus etc. yn minus 2, which also can be represented by the formula h by 3 into a plus 4b plus 2c, where a represents the sum of the first and last ordinate, and b represents the sum of the odd ordinates, and c represents the sum of the even ordinates. And all the values of y1, y2, etc. yn are calculated from each value of x. Now we are going to see an example problem using Simpson's rule. Evaluate the integral 0 to 1 e power x into dx by Simpson's 1 by 3 rule. And then here by ordinary integration also we solve this problem. But here you are going to find the approximate value of the integral. So we apply numerical method to evaluate the value of the integral. So now integral limit varies from 0 to 1. So we divide the interval range 0 to 1 into 6 equal parts. We determine the value of h equal to 1 by 6. And then next we are calculating the value of y0, y1, y2, y3, etc. y6. And then y0 starts with the value. Here limit varies from 0 to 1. So initial value is x0. Substitute the value of x0 equal to 0 and find out the value of y0. And then x1 we already determined, x1 which is nothing but x0 plus h. Substitute the value of x0 equal to 0 and h equal to 1 by 6. 0 plus 1 by 6 gives the value y1 which is equal to e power 1 by 6 which is equal to 1.1813. Consequently, we determine the value of x1, x2, x3, etc. x6. We determine the values of y0, y1, y2, etc. y6. Next, let us substitute all these values in the Simpson's formula h by 3 into sum of the h by 3 into y0 plus yn plus 4 times of sum of the odd ordinates plus 2 times of sum of the even ordinates. Substitute all these values, we get the approximate value of the integral 0 to 1 e power x into dx equal to 1.718. Here we determine the value of the definite integral. Integral function is e power x. So integral 0 to 1 e power x dx gives the approximate value of the curve 1.7182. This represents area of the curve in any shape. So in numerical integration, Simpson's rule is used to find area of any objects that is having any shape. We use the parabolic rule and find out the area of the parabolas and sum of all the areas of the parabolas. That gives the required area under the curve. That determines the area of the any objects. Thank you.